Hey everyone, it's Miss Bell here again from the Science Lab, and today we're going to be talking about another type of energy, light energy, which is a type of energy that we can see with our eyes. Now, the light energy that we get from the sun will obviously help plants and flowers and food and trees grow, which we need to survive. And light can be measured by how bright it is or how dim it is. So, does it produce a lot of light or a little bit of light? And there are even different types of light, such as natural or man made. Natural just means that it's found in nature. No one or no person makes it, such as the sun or stars or lightning or a firefly. And man-made light refers to objects that produce light, but either a person had to make that object or a machine had to make it, such as a cell phone, a candle, those cool shoes that light up when you walk on them, or even a strand of lights that you see during the holidays that you have to plug into a wall.
So when we're talking about light energy, we know that light travels in a straight line, but we can't ever really see those straight lines. We can see where the light is coming from, whether it's the sun or a flashlight or a candle, but we can't see all those straight lines on even how they get reflected or even refracted. However, with this short demonstration, I'm going to show you a way that we can see those straight lines of light. I'm going to use a laser pointer and a spray bottle of hairspray. I am going to turn down the light so it's going to get a little dark, but I need you to be able to see the laser pointer hitting the wall. Here we go. Okay. So here's my laser pointer. When I turn it on, you're able to see that beam of red light hit the wall, but you can't see the line of light. I can put my hand in the way like this, so I'm blocking the red light from hitting the wall. But if I take my can of spray like so and I spray it, we're going to be able to see that beam of light that's hitting the wall. Here we go. And with this short demonstration, you're able to see that straight line of light going from my laser pointer all the way to the wall.
And with this next activity, I'm just using a bunch of CDs clipped together with clothespins, and I'm lining them up in a straight line. And at the very end of my line, I have almost like a target. And my goal with this activity is to shine my light through all of those holes in the middle of the CDs to hit the target. And the way that I'm going to do that is because I know that light travels in a straight line. But as I move my flashlight from side to side, the CDs block the light, and I'm not able to see my light hit the target anymore. I can also use a candle as my source of light energy, and when I put my candle in the very back of my line of CDs, I can see that flame through all the center holes. But when I move my candle light from side to side, again, we're not able to see that light energy because the CDs are blocking those lines of light, and it's not visible to us from this perspective.
So for this activity, we get to look at objects with different levels of brightness or darkness. And all you're going to need for this activity is some sort of box that has a hole cut in the top where you're going to be looking into, and then a hole cut into the side where you're going to take some sort of light source, in this case a flashlight, and you're going to be shining the light on the side of the box. And then you get to peep into the top of the box and try to see, do I know what this object is? Can I take clues from what I can see from the light and make a decision on my guess of what that object is? And you can play around with how dark or how dim or how bright the light is. So for instance, right here, there's no light shining in here, so it's going to be pretty dark when you look into the box. But if you put the light to the side of the box, just like this, that's going to be one level of brightness. What if you open the box and you just have the lights from up above in the science lab? And then what if you add even more light? All different levels of light source or light energy being shined upon those objects to help you figure out how does an object look different with different levels of light.
So here I have the first object in the box, and it's very dark because there's no light coming from the side. Now I'm shining the flashlight through the small hole on the side, and you can kind of see because there's a little bit of light. Can you take a guess at what it is? What do you think? Now I open the door and we're able to see just a little bit from the light of the science room, and then I added more light from the flashlight. Do you know what it is now? Well, if you guessed keys, you're correct. Yay! And here I have my second object. Again, there's no light, but here I flashed or shined my flashlight in the side of the box, and you're able to see the little bit of light coming through. Now I opened the box and we're able to see with the science lab lights from above, and then I added the flashlight. Can you guess what it is? What do you think? Well, if you guessed a Lego piece, you were correct. And here is the third object in the dark box with no light, but here's my flashlight shining through, and we're able to see just a little bit of light. Can you take a guess at what it might be? Well, I opened the box and there's some light coming from the ceiling lights, and here is my flashlight. So more and more light coming through. What do you think it is? Well, if you said an eraser or half an eraser, you are correct. Ding, 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 ding. So here's my hand just wiggling around in front of a wall, and you can see the dark area on the wall, and we call that a shadow. And basically a shadow is just a dark shape made when something blocks light from a light source. It could be from the sun, from fire, from a flashlight. And since light travels in a straight line, it stops when it's blocked by something, and that's how shadows are created. When we see light and light hits different objects, those objects might appear differently with the amount of light that can maybe go through those objects. And this is a little advanced, but light might be considered transparent, translucent, or opaque. And when an object is considered transparent, that means that all the light passes through that object. So if you're shining a flashlight, at that object, like saran wrap or clear tape, you're going to see all that light shining through. But if something is considered translucent, that only means that some of the light is going to pass through that object, like wax paper. You're only going to see a little bit of the light. And if something is considered opaque, that means that no light passes through that object, such as foil. If I take a flashlight and shine it at foil, at the back side of the foil, I'm not going to be able to see any light that's passing or trying to pass through that piece of foil. And here I am just looking at objects and seeing what they look like when I'm shining the same light on them. So I'm trying to look at their shadows that they cast on the wall behind them, and I'm observing, what do they look like? What do their shadows look like? Can I see through the object? Can I see through the shadow? Are the shadows dark? Are they light? What do you think? When it comes to light energy, we know that people are able to see objects because of two reasons. It's because that object either gives off light, like the sun or stars or a sparkler, or because that object reflects light, meaning all the light kind of bounces off that object. So people are able to see the sun because it gives off its own light, but people are able to see the moon because it reflects the light from the sun. Light energy can be so fun to learn about and to explore and observe. Take for instance this mirror right here. The mirror is opaque, meaning that the light is not going to go through the mirror, but the mirror reflects all of the light that hits it. So I hope you guys enjoyed this video, and I'll see you guys next time. Bye.